Welcome back to day 5. We've spent the last few days talking about how machines learn from examples and how a trained model works. But there's one ingredient sitting underneath all of it, quietly deciding whether your AI is brilliant or useless. The data. Today, data gets the spotlight. I want to convince you that data isn't just one part of building AI. It's the single most important part. And to prove it, we're going to take a perfectly good model and wreck it, not by touching the model at all, but just by feeding it bad data. Let's dig in. Here's the metaphor to hang on to all day. A model is like an engine, and data is the fuel you put in it. You can have the most powerful, beautifully engineered engine in the world, but if you pour in dirty, watered-down fuel, it sputters and stalls. In AI, it's exactly the same. A fancy model trained on bad data will lose every single time to a simple model trained on great data. So when people obsess over which model is best, they're often looking at the wrong thing. The real magic and the real work is usually in the data. Let's make that concrete. A model only ever knows what its training data showed it, nothing more. So two things matter enormously. Quantity, having enough examples to learn from, which we saw on day 3, and quality, having examples that are clean, correct, and actually represent the real world. If there's a gap in your data, say you never showed it a certain kind of example, that gap becomes a permanent blind spot in the model. And here's the punchline that surprises people. In practice, improving your data almost always beats reaching for a fancier model. Data is where the wins are. Computer scientists have a blunt old phrase for this, and it's been true for decades. Garbage in, garbage out. Whatever you feed into training is what comes back out in the model's behavior. Feed it clean, correct examples, and you get an accurate, reliable model. Feed it messy, mislabeled junk, and you get a model that confidently gives you nonsense. Feed it biased data, and, we'll come back to this, you get a biased model. The training process itself is faithful. It learns exactly what you show it, which means the quality of what you show it is everything. Now, not all data is the same, and one distinction matters a lot. Labeled versus unlabeled. Labeled data means each example comes with the correct answer attached. A photo plus the tag cat. An email plus the tag spam. That answer key is what lets a model check itself and learn, like we saw. Unlabeled data is just the raw examples with no answers, a giant pile of photos with nothing telling you what's in them. Here's the catch. Labels are incredibly useful, but creating them usually means humans tagging things by hand, which is slow and expensive. And the vast majority of data in the world is unlabeled. That tension shapes a huge amount of how AI actually gets built. Let's put them side by side. Labeled data comes with the answers. It's what powers the supervised learning we'll cover tomorrow. And it tends to be costly because a human usually has to create each label. Unlabeled data is just the raw stuff. It's cheap and basically everywhere. And there are clever techniques to find patterns in it even without answers. Most real projects use a mix. You'll often hear that AI teams spend the bulk of their time not on the model at all, but on gathering, cleaning, and okay, time to prove all of this the fun way. We're going to take the exact same digit reading model from the last couple of days, the one that hit about 95% accuracy. We will not change the model one bit. We won't even change how much data it gets. The only thing we'll do is go in and start corrupting the labels, randomly scrambling the answer key. So the model is learning from increasingly wrong information. Then we'll watch what happens to its accuracy. Let's look. Here's the whole experiment. We loop over corruption levels, 0%, 30, 60, and 90. Each time, we take our correct labels and randomly scramble that fraction of them, literally replacing the right answers with random wrong ones. Look closely, the images stay exactly the same, the amount of data stays the same, the model stays the same. The only thing rotting is the answer key the model studies from. Then we train, and we test on clean, untouched images. Let's run it and watch the damage. And there's the carnage. With clean labels, 95%, beautiful. Corrupt 30% of the answers, and it slides to 83. Corrupt 60%, down to 70. And once 90% of the labels are garbage, the model collapses to about 31%, barely better than guessing. Same model, same amount of data. The only thing that changed was how trustworthy the labels were. This is garbage in, garbage out, happening right in front of us, as a number falling off a cliff. Let me show you that as one clean picture, because it's the whole lesson in a single image. On one side, the share of labels we've corrupted climbs from 0 up toward 90%. And watch the accuracy meter do the opposite, sliding down from the mid-90s toward the low 30s. The model isn't getting dumber. The fuel is getting dirtier, and the engine responds exactly the way you'd expect. The relationship is brutal and direct. The worse the data, the worse the model. No clever trick can save you from bad data. So burn this one into memory, because it might be the most practical idea in this whole series. Garbage in, garbage out. No model, no matter how big or how expensive, can be smarter than the data it learned from. If your results are bad, the very first place to look is almost never the model. It's the data. Is it clean? Is it correct? Is it enough? Is it representative? Fix the data, and the model usually fixes itself. And there's a serious flip side to this, one that really matters. It's not just random junk that hurts a model. It's biased too. If your training data leans a certain way, the model quietly learns that lean and repeats it. Train a hiring tool mostly on resumes from one kind of person, and it can start unfairly favoring that group. So here's the responsible takeaway. A model holds up a mirror to whatever world its data came from, flaws and all. That's exactly why thoughtful AI teams work so hard to gather diverse, representative, carefully checked data, and to actually measure fairness rather than just assume it. Good data isn't only about accuracy. It's about building something that's fair and trustworthy, too. The data is where the responsibility lives. Let's pull it together. Data is the fuel of AI, and more than anything else, it decides how good your results will be. Garbage in, garbage out. We literally watched a great model crumble on poison labels. Labeled data, where each example carries its answer, is powerful but expensive to create. And bias hiding in your data becomes bias baked into your model. So the next time you hear about an amazing or a troubling AI system, your first question should be, what data was this trained on? That question takes you straight to the heart of it. So that's why data is the fuel of AI, the quiet ingredient that decides whether your model soars or stalls, and whether it's fair or flawed. We've now mentioned this idea of learning from labeled examples a few times. Tomorrow, we're going to give it its proper name and dig right in, supervised learning, the single most common and useful way machines learn today. Once you get it, you'll start recognizing it everywhere. Thanks for building with me today. See you tomorrow on